Welcome to SanfordFlipMath. We are in PreCalculus, working through the Demana Waits Foley Kennedy book. We are in section 5.3, which is going to add on to our list for trig identities. In fact, we're going to add these three to the list. They are ugly, they are scary, and you need to know them. Okay? I will say that if you can kind of focus on these two specifically big time, and then based on those, because of this guy, you can actually ignore this one. But I will tell you that it's going to be easier if you know it. It's probably worth knowing. But if you're at the spot now where you're already doing triage because you know we have a test coming up and you're trying to make good decisions, then focus on sine and cosine, and tangent you can make happen. Okay. So the question is, what's going on? Why do we need it? And hopefully this sheet will answer that question. So following order of operations, we're just going to kind of fill these numbers in, and then we'll come back to the identities in just a second. Order of operations means we got to add first, so this is going to be sine of 90, and hopefully you remember that that is 1 from the unit circle, or you could do that in your calculator, I suppose. Cosine of, this is going to be the cosine of 15 degrees. Well, the cosine of 15 degrees, as I'm grabbing my calculator, cosine of 15 is 0.9659 and a bunch of stuff. Okay? And then tangent of 75, okay. Well, tangent of 75 is 3.732. Okay. Sine of 30 is 1/2 sine of 60, square root of 3 over 2. Add those together and you get 1 plus the square root of 3 over 2. That's great. Okay, which is, if you want the decimal approximation, 1.366. Okay, cosine of 60 minus cosine of 45. Well, cosine of 60 is 1/2. This is square root of 2 over 2. And sure, I can do that in my head. It's about negative 0.207. Now, again, if you wanted to just say 1 minus square root of 2 over 2, that is really what it is. This is an approximation. Okay, and one more time, tangent of 45 is 1, tangent of 30 is square root of 3 over 3, so this becomes 3 plus the square root of 3 over 3, which is, of course, 1.577. Okay, so what's the point? Why do we care about this? Why are we doing all this foo-foo calculator stuff? Well, here's my point. Look across. Sine of 30 plus 60 is not the same thing as sine of 30 plus sine of 60. This one is not equal to this. They are not the same. I mean, the numbers that were there were correct. They're just not equal to each other. Okay. Similarly, cosine of 60 minus 45 is not the same thing as the cosine of 60 minus the cosine of 45. Tangent of 45 plus 30 is not equal to the tangent of 45 plus the tangent of 30. So what's a better way to say this? Here are the tangents with both of these. Here are the tangents with this quantity. And the idea is that sometimes people get tempted to do this thing, and you can't. Okay? So the moral of the story, you cannot distribute trig functions. Okay, big time. Now, okay, for logarithms there were special properties about adding and subtracting and multiplying and dividing and stuff, and for trig functions as well. Okay, so I know you've been kind of playing with stuff like this forever, and you say, sweet, I can distribute that, and you can. You can distribute multiplication across addition or subtraction. That's pretty much it. Okay. So what do we do? Well, that's the first one. That is the first rule for sum and difference identities. And the question then becomes, why do we care? Well, sometimes you need to find things exactly based on things that you know. Okay, so 30 plus 60, we already know the sine of 90 is 1. I just want to use an example that we already know what to do. Okay, so please understand that here's A, and here's A. Here's B, B, and B. You have to follow this format, and note it's sine, cosine, cosine, sine. And so the sine function, sine follows the same sign. There's this addition here, there's addition here. Okay. And so if I want to figure out, one way to figure out the sine of 30 plus 60 would be to follow this format. So equals sine of, so my A here is 30. So it's going to be sine of 30 here, and it'll be cosine of 30 here. And then for 60, that's my B. Okay, so this will be cosine 60 and sine 60. Okay, and at this point, I just need to do all these little calculations and combine things. Okay, so the sine of 30 is 1/2. The cosine of 60 is also 1/2. I'm remembering these from the unit circle. The cosine of 30 is the square root of 3 over 2, and the sine of 60 is the square root of 3 over 2. So as I simplify some of this, so this is going to be 1/4 plus square root of 3 times the square root of 3 is 3. 2 times 2 is 4. So all of that added together is 4/4, which is 1. Now I know you're saying to yourself, Self, I knew that. Okay. Well, what if instead we were going to do the sine of 15 degrees? And I want to know this exact. Okay, exactly. Sine of 15. All right, well, I could go to my calculator. Sine of 15. Check that I'm in degree mode. Okay. And I hit enter, and it's set, 0.2588. That's not looking so exact. I'm just going to make a little quick note here, 0.2588, so when we're done we can do a little checkage. Okay. Sine of 15. Okay. What we're going to be doing is all of the problems that we're going to be working on are going to be based on multiples of 30 or multiples of 45. Okay, and now keep in mind that they might be in radians, and that's okay too. Okay, and my advice on this is just put it in degrees and work with that. Okay, now I need to show you a slightly different version of that rule we just did. We could have, instead of plus, it could be minus, and if that's true, then this is plus or minus. So this same rule applies for addition or subtraction, and now we're going to think, how can I make 15 out of 45 and 30? Well, how about 45 minus 30? Or it could be 60 minus 45. Or it could be, I mean, there are other ways to do it, but find the easiest way to make it happen. Okay? All right, so the rule says, okay, so let me write the rule again. Okay, it says sine of A plus B equals sine, cosine, cosine, sine, and it's AB, AB, and if this is plus, then this is plus, and if this is minus, this is minus. Sine follows the same sign, but there are different functions together. It's sine, cosine, cosine, sine. Okay, so here we go. We're going to do sine of 45 minus 30, and I'm just going to follow that template. Okay, so my A is my 45, and so I'm going to do sine of 45, and over here I'm going to do cosine of 45. I'm going to do, the B is my 30, so I'm going to do cosine of 30 and sine of 30. And again, I'm following the sign that's in here. This was minus, so this is minus. Okay. All right, so here we go. Sine of 45. Now this is where that whole unit circle thing is going to be critical. Okay, so square root of 2 over 2, square root of 2 over 2, that's all for 45. This is square root of 3 over 2, 1/2. That's for 30. All right, so sine of 45, square root of 2 over 2. Cosine of 30, square root of 3 over 2. Minus cosine of 45. Well, that's this one. 2. Sine of 30, that's this one. Okay, clean it up, wrap it to go. So what we're going to do is write square root of 6 minus square root of 2 over 4. Okay, quick little side note here. Square root of 6 minus the square root of 2 is not equal to the square root of 4. Not the same thing. You cannot undistribute or factor out a square root and call that square root of 6 minus 2. Illegal, can't do it. Can't divide out anything here. This is, as we like to say in the biz, done. All right, quick little note here. If I go over here and do square root of 6 minus square root of 2, okay, so I need parentheses. Square root of 6 minus square root of 2. Oh, forgot I'm on a new system here. Boop, 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 boop. Okay. Okay, let's do that. Okay, so square root of 6 minus square root of 2 all over 4. I just want to see what this is equal to. 0.2588, which is, so that's a great way to check. Okay, this is how your answers are going to look for this section. They're going to look something like this most of the time. They don't always look exactly like this, but these numbers are going to become very, very, very common. Okay, different rule. Unfortunately, sine and cosine don't follow the same rule. Okay, so cosine has the same function together. And it's still that AB. And here's the weird thing. If this says plus, this says minus. If this says minus, this says plus. Okay? So they have the same, it has the same function together, but opposite signs. Okay? Whereas sine, whoop, too far, had the same sign together. In other words, if it's plus, but opposite functions. Okay, so instead of sine, sine, or cosine, cosine, it's sine, cosine, cosine, sine. Okay. All right, so here's the idea. What if we wanted to do the cosine of 75 degrees? Well, cosine of 75, I'm going to think about that like cosine of, well, what can you do with 45s and 30s to do that? Well, I guess it's just 45 plus 30. Okay, so following this rule then, I can just, here's my A, and here's my B. Okay, so following A, I'm going to do cosine of A. Sine of A down here, remember it's cosine, cosine. Sine, sine. That is funny. I wrote A. Not so clever, Sanford. Okay, too distracted. Sorry. All right, cosine, cosine, sine, sine. There we go. Okay, and remember that it has to be opposite signs. So if this is plus, this is minus. Okay, so for cosine, it's cosine, cosine, sine, sine. You want to sing it, don't you want to sing it? I do. Cosine, so sine, 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 cosine, all right, that's enough of that. All right, same unit circle setup. Cosine of 45 is square root of 2 over 2. Cosine of 30, sine of 45, sine of 30. Told you these numbers come up a lot. So square root of 6 over 4 minus square root of 2. That was close. Over 4 square root of 6 minus square root of 2, and you still can't subtract them. Leave it alone. Okay? Check it in your calculator, see if cosine of 75 degrees in degree mode gives you the same decimal as square root of 6 minus square root of 2 over 4. Okay, so the idea is that this is exact. There is no rounding going on here. Okay? There are times when that's useful, and we need to be able to handle that when that happens. Okay? All right, let's do another one. Let's do something less pretty. Okay, so what the heck is that? 7 pi over 12. All right, well, this is much easier to do in degrees. I will confess that even I don't think in radians this well. I mean, even if I do, I'm converting in my head. Okay, so here we go. 7 pi over 12 times 180 over pi. Okay, so we're just converting. Okay, now I know some stuff's going to cancel out here, or divide out here. Sorry, math teachers listening to this freaked when I just said cancel. I'm going to divide out a common factor. I bet that whole 12 will divide out. But let's just start with what we know. I know 6 will go into this. 30 times 6 will go into the 2 times. There you go. And then we can divide out a common factor of 2. So that's 15. That's 1. Now, so the denominator is gone. And so 7 times 15, and I believe that is 105. Okay, so I really want to do the tangent of 105 degrees. So you say to yourself, multiples of 30 and multiples of 45. It's usually easiest to identify the 45 first, and then just see what's left, or do some adding or subtracting or something. So this is actually equal to the tangent of 45 plus 60. Again, I can't distribute. All I can do is work with identities. Well, I will tell you there is a tangent identity, and it works really well, and it's based on sine over cosine. So I'm going to do this first with just sine over cosine, because one, you can do it that way. Two, I'm trying to sell the idea of learning the tangent identity as well. Okay, it'll make things a little easier. All right, so sine, I have two identities that I need to follow here. Okay, so remember that sine has the same sign and opposite functions. So this is going to be sine, cosine, cosine, sine. Okay, just a quick check on yourself here. That, sorry, I got degree symbols all over the place that need to be there. Sine has to be with 45 and cosine has to be with 45. Okay, it's not a guarantee that you're going to have everything in the right order, but at least it helps you take attendance. Okay, cosine has the same functions together. So cosine, cosine, sine, sine. So cosine starts with cosine. And remember, it has opposite functions, opposite sign. So if this is plus, this is minus. Okay? Well, at this point, it's just a matter of calculating. Sine of 45, square root of 2 over 2. Cosine of 60 is 1/2. Cosine of 45, square root of 2 over 2. Sine of 60, square root of 3 over 2. Over, yeah, you'll love this. Cosine of 45, square root of 2 over 2. Don't do it. Cosine of 60, well, cosine of 60 is also 1/2. We saw that a minute ago, right? Minus square root of 2 over 2 for the sine of 45, and sine of 60 is, square root of 3 over 2. And the answer is no. You can't divide this stuff out. Okay, these are connected by addition and subtraction. There is some multiplication here, but if you start doing stuff like this, you can't. Now, if there's a square root of 2 in common with every single term, okay, I'll give you that one. That actually is true. I'm actually not going to do it though because it doesn't normally happen that way. I just want to do this the kind of straightforward normal way. Okay, and let me bring that back down. All right, so I'm going to do some simplifying here. So square root of 2 over 4 plus square root of 6 over 4 over square root of 2 over 4 minus the square root of 6 over 4. Well, this is kind of like a lot of stuff. Now, one of the things that we learned, we've kind of done it here and there quite a bit. If you have complex fractions, in other words, fractions inside of fractions, if you multiply the top and bottom by the common denominator, you can clear those fractions. I mean, do you like fractions? I'm not a big fan. I mean, fractions happen, like a lot of things happen, but that doesn't mean I have to like them. So 4 times square root of 2 over 4, 4 times square root of 6 over 4. Similarly, okay, and what you need to be saying to yourself is, dang, I wish we were done. And I know you do, but we're not, because we aren't supposed to leave square roots in the bottom. So I need to multiply the top and bottom by the conjugate. Okay, and it's the conjugate of the denominator. We're getting close. I know it doesn't feel like it, but we are. On the bottom, because that's the area of concern. Square root of 2 times square root of 2 is 2. Outer would be the square root of 12. Inner would be the square root of 12 only minus, so don't worry about simplifying that. And then last times last would be minus 6. So when all is said and done on the bottom, bye-bye, negative 4. On the top, square root of 2 times square root of 2 is 2. Outer, inner, last, okay, well, things don't cancel out up here. They don't divide out. So this becomes 8 plus, well, this is 2 root 12, but the square root of 12 also simplifies into 2 root 3. So 2 root 3 times 2. Now I have two things that are being added or subtracted, but I actually have a common factor of 4 in every one of those. And I'm going to go ahead and divide by negative 4. So 8 divided by negative 4, and 4 divided by negative 4, the square root of 3. Whew, doggy Jethro. That is a lot of stuff. Okay. I know that you want to be done, and so do I. But the problem is that we're not. And I need to show you the last identity, which is based on sine and cosine, and I'm not going to show you algebraically where it comes from. I believe it'll happen in a classwork problem. But the rule is this. And you just saw that you can do this without the rule. It's just more work. Okay, so worth noting that on the top it has the same sign. On the bottom it has the opposite sign because it came from sine over cosine. Okay, and sine would have had the same sign on the top, and the bottom would have had opposite sign on the bottom. Okay. Okay, so just a second ago, the problem we were doing was the tangent of 105. Tangent of 105, which we broke up into the tangent of, I believe it was 45 plus 60. Okay, 45 plus 60, yep, okay. All right, I'm going for broke. Following the rule. Okay, so this is A. Okay, so tangent of 45 plus, because it's the same sign. Okay, so this is B, B, B. Tangent of B over, this is always 1, and again remember it's opposite sign, so tangent of A, tangent of B. So I really only need to know 2 trig functions to do this. I don't have to know all 4. Tangent of 45 is 1. Tangent of 60 is the square root of 3. You can work with your unit circle to do that. 1 minus 1 times square root of 3. Okay, clean this up just a little bit more, and then we'll get rid of the square root on the bottom. Okay, so again, we can't leave it like this, but it already looks better, and notice I did this in 2 steps, basically. I have to multiply by the conjugate of the denominator. Okay, so all of this becomes, I'm going to do the bottom first, so this is 1 times 1. Outer and inner will cancel out. Last times last will be minus 3. Okay, so the bottom just becomes negative 2. The top, well, 1 times 1 is 1. Outer is the square root of 3. Inner is the square root of 3. Last will be the square root of 3 times square root of 3 is 3. So this is going to be 4 plus 2 root 3. Okay. I can divide everything by negative 2, so this becomes negative 2 minus the square root of 3. All right, so I'm going to do the slow scroll. Negative 2 minus the square root of 3. Negative 2 minus the square root of 3. Same problem, 2 different ways. I can do it by doing sine over cosine, or I can know this extra rule. That's the decision that you have to make. Okay. All right, so all of that to say that we have 3 new rules now. 1 more section, and we'll learn like 6 different identities in there, and you can narrow that down a little bit. All right, well, thanks for hanging with me. And if I haven't said it 100 times, memorize the identities. Memorize the identities. There are actually more identities than what you see on this shortened big list. So you have to pick and choose the ones that you need to focus on to get the job done. I think you absolutely need these 2 from this one. Life is easier if you know the tangent rule, but for sure you need those 2. That one, these you already know. Not a big deal on the odd even stuff, maybe. And this is not a big deal either. Sorry, that's supposed to be a question mark. All right, well, thanks for hanging in. SanfordFlipMath, it's way past time to be done. Bye.